Welcome to Stats 1, Probability. You might be used to thinking about probability as intuitive fractions based on rolling dice or flipping coins, but in A-level mathematics, we leave pure intuition behind. This unit elevates probability to a rigorous, formal discipline. It is the crucial bridge between observing raw data and building predictive models, and it forms the mathematical engine that powers Paper 5. If you cannot accurately calculate the probability of combined events here, you will not be able to handle the advanced statistical distributions later in the course.
We begin by establishing the formal language of chance. Everything starts with defining your sample space. This is the complete set of all possible outcomes of an experiment. An event is simply a specific subset of that space. Getting this definition right is the absolute first step before you even touch your calculator. You will learn to use strict set notation to describe unions, intersections, and complements.
Next, we explore what happens when multiple events interact. This is where students frequently lose marks by confusing two entirely different concepts. Mutually exclusive means two events absolutely cannot happen at the same time. Independent means they can happen together, but the outcome of one has zero effect on the probability of the other. You will learn to stop assuming independence and instead rigorously prove it using the formal addition and multiplication rules.
Then we tackle the most challenging scenarios, conditional probability. How does the probability of an event change if we are given new information that another event has already occurred? The primary discriminator between a B grade and an A-star candidate is translation. When an A-star candidate reads "given that" or "if" in an exam question, they immediately write down this exact formula. You will learn to spot these linguistic triggers and apply them flawlessly.
Probability problems can quickly become overwhelming if you do not know which tool to apply. To untangle complex scenarios, you will master two powerful visual frameworks. For sequential events happening one after another, like drawing multiple items without replacement, you will construct fully labeled tree diagrams. But for overlapping, non-sequential events within a single population, you will build Venn diagrams. These visual models allow you to map out overlapping conditions and solve complex problems without getting lost in the algebra. By the end of this unit, you will have a specific mathematical framework for every possible probability scenario. You will confidently translate descriptive English into formal set notation, mathematically justify whether events are independent or mutually exclusive, and choose the perfect visual model to secure full marks. You are building the foundation for all statistical inference.